We're going to take a look at how to create an empirical formula using mass composition data or percent composition data. In this example, we have information about the compound, and it was found that this compound is 39.971% carbon, 13.416% hydrogen, and 46.613% nitrogen. We need to determine the empirical formula, and from the empirical formula and finding out that the molar mass of this compound is about 90 grams per mole, we want to see if we can create the molecular formula. So just as a reminder, the empirical formula is the lowest whole number ratio. So we are going to be trying to use this percent composition, which is about the mass. We want to use this data and create a lowest mole to mole ratio. And the way you do this is you have to follow a set of steps. And so our goal is to eventually get whole numbers, but we have to go through the process. This data is mass data, that is a relationship of the percent composition. And so the first thing that we want to do is change the percent to mass. So we want to take each of our percentages and look at them individually. And so the percent composition of carbon, 39.971, the percent of hydrogen, 13.416% hydrogen, and the percent nitrogen, 46.613% nitrogen. So percent to mass, what this means is you just change the percent sign to grams. Nothing else besides that. And so we're going to take each of these percentages and we're just going to rewrite it as that same number of grams of the element. So be sure to put the element symbol right after it. Since our goal is to figure out the lowest mole to mole ratio, we have to convert grams of each element into the moles of the element. And so that is our next step. We want to convert from grams to moles. And this, again, this creates a mole to mole to mole ratio of the elements. And that is what a chemical formula is. It is a mole to mole to mole ratio of the elements in the compound. And so to go from grams to moles, we have to use the molar mass of each element. And so the molar mass of C is its atomic weight in grams, so 12.011 grams of C, same thing as 1 mole. Hydrogen, 1 mole of hydrogen has a molar mass of 1.0079 grams hydrogen. And nitrogen, 1 mole of nitrogen, 14.007 grams. So all we're doing is we're taking the atomic mass of the element from the periodic table. It doesn't have a chemical formula yet. That's what we're trying to find. And so we're not adding it to anything. We're just looking at each individual element. And so you're going to take each of these and divide it by the molar mass. So for carbon, we get 3.327866123 moles of carbon. For hydrogen, we get 13.31084433 moles of hydrogen. And for nitrogen, we get 3.327836082 moles of nitrogen. So now we have a mole to mole ratio. This is a moles to moles to moles ratio. Moles to moles to moles. But we want in an empirical formula for them to be the smallest, and we also want them to be whole numbers because formulas have whole numbers. And so our next step is divide by the smallest, and that's the smallest number. So with the ratio, we want to keep it consistent, but we want to reduce the ratio to the smallest possible number. So the smallest possible number is a 1. And so we look and we find our smallest number, which is this nitrogen number, and we're going to divide that number into each of our values. So we're dividing the number, not the unit. And so that creates, the smallest number becomes 1. Okay. And then our next number, we would take the 13.310844433, and we're going to divide it by 3.327836082. And we get 3.99984 moles of hydrogen. And then we're going to divide it into the carbon. And so 3.327866123 divided by 3.327836082, and we get 1.000009. Okay, our last step is to multiply until whole. So what we have to do is any number that wasn't the 1 is going to be some decimal number of moles. You want each decimal number of moles to be within a few 100ths of a whole number. And so if we look at our values, this is 3.999. So if we go to the 100th place, well, this is less than 1/100th away from being 4. So this is a whole number. And so that's a whole number of 4. So we're going to write that as a 4. And then this one, if we go to the 100th place, we'll see that it's 1.00. So this also is a whole number. So we don't have to multiply by anything. And this, of course, is a 1. So our empirical formula will have carbon 1, hydrogen 4, and 1 nitrogen. So to write that, this ratio becomes our chemical formula, C1H4N1. This is our lowest possible ratio of elements in this compound. But we were given the information that this compound has a molar mass of 90. So an empirical formula is the lowest whole number ratio, which means this could be 1, 4, and 1, or it could be 2, 8, and 2, or it could be 3, 12, and 3, or 4, 16, and 4. That would be the molecular formula, which is the actual number. The actual molar mass is about 90 grams per mole. So it's not taken to the degree of precision that we usually do. And so what we have to do to figure this out is, if we want to go from the empirical to the molecular formula, you have to be given the compound's molar mass, which is when you add up all of the elemental masses, add them together, and that is the molar mass. If you're given that, then you can take the empirical and scale it up to molecular. The way to do that is you have to compare the empirical formula mass to the given molar mass so that we can change the subscripts to the correct ratio. So we have to add up the molar mass of this substance. And so if we add it up, we would put 1 carbon and 4 hydrogens and 1 nitrogen. So that's about 30. So I'm just going to put it at 30 because I'm comparing it to 90. And so in order to create the correct subscripts, this is the lowest ratio of something. And so this has to be the same ratio. And so this has to be a factor of this. So you want to either divide this into here or think to yourself, what do I need to multiply by? And so in order to go from 30 to 90, we would need to multiply by 3. So what that means, in order to go to the correct number of atoms, we're going to take each subscript and multiply them by 3. We have to scale it up by a factor of 3. And so we multiply the carbon times 3, the hydrogen subscript times 3, and then the nitrogen subscript times 3. So this is the actual molecular formula for this compound. So this compound has 3 carbons, 12 hydrogens, and 3 nitrogens. The lowest ratio was what we got using our steps, 1, 4, and 1. You can double check and make sure if we add up 3 carbons, and if we're just doing to the ones place, we'll just do to 12. And then 12 hydrogens at 1 each, and then 3 times 14, that's 90. And so this equals the 90, and it also, if you factor out a 3, you can get back to 1, 4, and 1.